Good morning time, good afternoon time, good evening time, whatever the case may be in your part of the world. Once again, back with another video. This one we're going to discuss briefly. Now I'm going to keep this one short and sweet. Just talking about helping your motor dissipate some heat, because it is super hot right now. We got a heat wave going on, and if you haven't been having overheating issues, you may start having some with this heat. It's certainly not going to help, and especially if you're running a whole lot of extra power. If you're running minimum power or the suggested rated power, you're not going to have any issues. But if you're exceeding those power levels 2, 3, 4, 5, 10 times, you're going to have some issues. And most guys already know, but in case you don't know, there are a few ways you can combat that heat, especially in a direct drive. And this is a direct drive motor that I have taken apart. And over here we have a geared hub drive motor. And difference being is in the name, geared. A geared hub drive has actual moving parts on the inside. It has gears. It has a planetary gear set where there's a sun gear and little planetary gears that revolve around that. And reason why I've always been a fan of direct drive, there's less moving parts, and that alone makes them more reliable. Less parts that can break, less parts that can wear out, and yeah, for that reason, they're a whole lot more reliable, like I just said. Okay, so as you can see, this is the stator. This is the only actual moving part. It's all one piece, and normally in most motors, it's the opposite. The motor, part of the motor revolves around the inside, but the stator, makes it so the hub revolves around it, and this stays stationary. So there's a term for that. Of course, I'm having my old man moment. Maybe I'll think of it before this video is over. Oh boy. But anyway, back to how we can help with cooling those off. These are heat sinks, and these mount around the hub of your motor. You have to put them inside the spoke area, and they attach around the hub. And before you attach them, you apply some heat transfer grease to the inside of this, and then you connect them around the hub motor like so. And there's little screws that lock each one, lock them all together. But like I said, instead of you just don't put them on like that, you have to use that heat transfer grease. And that makes it easier for the heat to be able to move from the motor out to these heat sinks, where the heat can dissipate off of those fins. Now, another problem as far as dissipating heat is when this stator is actually inside of the hub, there's a gap between these iron plates, because these are electric magnets, and these are natural earth magnets. They're really close together when it's assembled, but there is a gap I mean, it's very small, maybe a millimeter or two, but that gap alone is an air gap, and that air gap won't allow an efficient transfer of heat because it actually has to travel across that little gap. So in most motors, what they do is fill them with oil, and the fluid, allows the heat to move through the fluid to the outside of the casing and then dissipate the heat. But you can't really put oil inside one of these hub motors, although people have done it. It hasn't worked out very good. Obviously, a whole bunch of oil in there sloshing around would cause a whole lot of resistance, and you don't want any resistance in your freewheeling hub motor. So that doesn't work too good. So what they've come up with is using ferrofluid. Now, ferrofluid is the same thing as what they refer to as stator aid, but it's actually ferrofluid. Ferrofluid is a magnetic liquid. It's magnetic. So what happens is, when you put it inside of your hub motor, it automatically attracts to these natural magnets and the electromagnets when they're energized, and it just fills in the gap between the two. And filling in that gap allows the heat to transfer from the stator to the outside of the hub motor. And once it transfers to the outside of the hub motor, the heat can then dissipate from the aluminum hub itself. And then to help dissipate that heat, we have put these heat sinks around it. And that makes the heat dissipate even better, because the heat radiates out onto these fins, and of course these fins allow air to move across them, and that cools the metal casing down. If the metal casing is cooling down, it's allowing the internal stator to cool down. But you gotta have that fluid inside, in between these iron electromagnets and the natural magnets, to help bridge that gap. So yeah, and you don't have to, let me tell you a little secret, you don't have to buy what they call stator aid from an electric bike company, because they charge very high prices for that. You can actually go on Amazon and look up ferrofluid. It's used in all sorts of things. They got little experiments with ferrofluid. They got little all kinds of little stuff that uses magnetic liquid to do what it do. But you can buy it on Amazon. You can get I think like a 64 ounce bottle, something like that, for about $11. Not very expensive. You buy it from an e-bike shop, you'll get a little teeny bottle like that, and you probably will pay $40 for that same little teeny bottle. But you don't need a whole lot. It's only a couple ounces that you use, if that, depending on the motor and how you apply it. You could actually take the cover off of your hub motor and use a dropper and apply it around the edges in that gap. Or if you don't want to open up the motor, what they do is they drill a hole in this and use a syringe and inject it in there. Now, you have to be careful, of course, when you drill a hole through there, because you don't want to drill into your core. So that's why they suggest that you drill closer to the inside of the hub. If you notice on the stator, if you're drilling closer to the inside of the hub, closer to the axle, you're drilling into this part right here where you really can't do a whole lot of damage. You still can accidentally, if you just have bad enough luck that you you picked a spot right where the wires come out for your hall sensors, you could drill through those. But you know, the chances of that, well, you see it, but it can happen. But like I said, you want to drill pretty much, I would say pretty much like in the middle of here, and drill a hole. Like I said, you use a syringe to inject the fluid, and then you use some type of tough tape or, you know, anything to seal that hole up and keep the fluid from coming out. They have special little patches. I can't remember exactly what the little patches are called, but it's just basically a little patch of tape that covers the hole and keeps the fluid from coming out. Okay, so the term that I was forgetting in the beginning of this video, my brain freeze has unfroze, and the two different type of motors is called the in runner and out runner. An in runner is what it sounds like. You know, if you have a motor casing, the inside is spinning, you know, the axle is spinning, like in most little electric motors, the axle part is spinning. If you have an out runner, like what we use on our bikes, the axle is secured and the outer part spins around. So out runner and in runner. So these are out runners. Yeah. If you've never seen what a gear hub motor looks like on the inside, I'll show you. And another thing I want to help you guys with, if you never opened one of these motors, let me tell you how. First thing you're going to do is, if you notice on this cover, there's screws around the outside of it. They're normally Torx or Allen screws, and you remove those. Once you remove those, most people, if you want to do it the so-called correct way, you use a gear puller. And a gear puller, you know, once you attach it, will draw that cover off. But most people do it the old school ghetto way, and that is you remove these screws, then you can grab your rim, you know, like a steering wheel, one hand on this side, the other hand on the other side, and you can take it on something firm like that wood, and you can actually bang the axle onto the wood, and it will pop out the middle. Kind of like, let me show you real quick. This one will come right out, kind of easy, but with me holding this phone, if I can see, if you can push down on it. See how I pushed down on it and it popped out? This one pops out kind of easy. And you take it out, and this is what a planetary geared motor looks like on the inside. As you can see, there's a geared track around the outside of the hub, and you have these planetary gears. In the middle, there's another gear called the sun gear. When that one spins, it causes these to rotate around like such, and that will align in that track and spin the hub motor around those planetary gears. These plastic gears here are what normally breaks in these motors, which is kind of hard to do unless you are overvolting them. You go to 72 volts, you'll easily break one of these plastic nylon gears, because at that point you'll have a whole lot of torque, and this torque is what does it. you can replace these nylon gears with steel gears, and that eliminates that problem. But the main difference between a planetary geared motor and a direct drive motor, most planetary geared motors have a lot more torque because you're using a smaller gear and other small gears. And I mean, that, you know, the physics of that give you a lot more torque but less top speed. On a direct drive, you just have this main stator, and like I said, the hub spins around that. And hub motors are better for, direct drives are better for top speed. Now when you hear them use terms such as 5T and 3T, basically that just means 3 turns. If you look at these coils, you see this thick braid of copper strands. It's a whole bunch of them together, and what they mean is around each one of these little iron bars, a 3T would have 3 turns. 3 turns of this bunch of wires around each one. Each one has 3 turns around it. A 5T motor would have 5 turns of this copper wire around it. And what that does is vary the overall resistance of this motor, the impedance. Every motor is going to have an impedance if you measure the resistance across the phase wires. Some will have a higher resistance, some will have a lower resistance. The ones with a higher resistance require more current, and you know, that changes your RPMs depending on the current, because however much current is flowing determines the final output power as far as your wattage, and all that variation you know, determines your output watts. We ain't gonna get all deep into that, but just so you understand what they mean when they say 3T and 5T. Now this is a cheap Chinese motor here, and as you can see, they're not as premium as the good motors. You can look at this coil right here. When they were wrapping that one, it looks like they over wrapped it and had a bunch of wire, and they just instead of rewrapping it, they just mashed it down in there. So I mean, little slight anomalies like that, it really doesn't affect this motor too much. But in a more premium motor, you won't have stuff like that, you know. And right now the Hall sensor board isn't in there. It's been disconnected. Matter of fact, let me see, I have one over here, because you can replace Hall sensors. You can replace the whole board like this. This is the Hall sensors. There's 3 on there, and most of the times just one goes bad. You can replace them individually, or you can buy this complete board. You buy this complete board. They're not hard to change. As you can see, they're color coded. You will remove this whole board. Normally it's mounted to the stator like that, and these Hall sensors, they have a little slot in these iron cores, and the Hall sensors slide into each one slides into a slot, and you just connect the wires back, and bam, you've replaced the whole entire set of Hall sensors. And normally this is glued down with some high temperature silicone glue that keeps it in place, and then they zip tie it and wire tie it in there, and it doesn't move. But yeah, these are Hall sensors. The same thing with this geared motor over here. They're in a different place. This is the circuit board for the Hall sensors in this geared motor. They're located over here, and when the hall sensor's blowing this, you have to remove this whole circuit board, and they'll have, matter of fact, you can see where one of these hall sensors broke on this motor. The legs broke off, and that's what's wrong with this one. So I'll have to replace that. Let's see, I have some of this little box right here individually. Let you see what those look like. This is a individual hall sensor right here, and what I would have to do is take this board out and, you know, solder this one back on the board and secure it back in place, and this motor would be good again. Just haven't done it. Really ain't no need unless somebody wants a 750 watt motor. I'll go ahead and fix it. And this is a 1500 watt direct drive, and this was Frank's old motor where I upgraded the phase wires. You know, this motor, because it was originally 1500 watt, had little 18 gauge wires that went inside, and you can upgrade these motors by putting some 10 gauge or 12 gauge wire in there, and that allows more current flow. That allows this motor to be able to produce more output power. So yeah, there's that. And another difference in this motor and a premium motor would be these premium hall sensors. These are really good hall sensors. They cost a little bit more. They last longer. They handle voltage a little better. They're more precision as far as their ratings. The cheaper hall sensors won't be as precise as far as their values. And like I said before, when it comes to precision electronic parts such as resistors, capacitors, transistors, the premium ones, whatever value they're rated at, if you go to measure them with a multimeter as far as you know, whatever they should be, their ohms or whatever, it will be exactly, if it's 100 ohms, it will be exactly 100 ohms on the dot. That's precision. If it's a non-precision resistor, non-precision 100 ohm resistor might measure 101, 102, 103. You know, normally there's a tolerance rating like 5%, 10%. If it's 5%, it's within 5% or what it should be. 100 ohm, it'll be either 5. Anyway guys, my video got cut off. I forgot exactly where I was, but I think I was just talking about Frank's progression as far as controllers. Now that's not exactly the controllers, but that is a progression of about I think that first controller is like a 15 amp. That one is a 17. This one is a 25. This one is a 30, and that's a 45. What Frank has in there now, one exactly like that, and that's an 80 to 100 that I'm getting ready to put in Frank. But yeah, all right, guys, that was it. I hope you got a little something from what I was trying to get over here as far as dealing with the heat and how it impacts your bike and your motor, and what you can do to make things better. If anyone has any other questions or something they need help on, you know, let me know in the comment section, man. If I know about it, I'll make a video about it. If I don't know about it, I'll go research it and learn about it and make a video. Alright, y'all know what it is. Deuce, Crooked Finger Production.